All right, now that we've spent so much time talking about statistical significance and p-values less than 0.05, it's time that we talk about studies where the p-value is greater than 0.05, so-called negative studies. In this brief talk, we're going to explain what a negative study is and what an underpowered study is, and give you a rule of thumb to tell the difference. We're also going to address the ethical implications of underpowered studies. But to get us started, we're going to take it to the streets and find out whether Yale men or Yale women study harder. How many hours would you say you study per week?
About 45 hours.
45 hours, that's a long time. How many hours per week would you say you study?
I'd say around 30.
12 maybe?
How many hours per week do you study?
About 10.
Probably around 15.
How many hours per week do you study?
20.
So thanks for joining me out there. And basically what we found is that the Yale women studied on average 20 hours per week with a standard deviation of 10 compared to the Yale men who studied 24 hours per week with a standard deviation of 18. Of course, I only asked 3 women and 3 men, and the p-value I calculate, in fact I just put this into my good old student's t-test that you just learned about, was 0.83. So that is much greater than 0.05. We would say that's not statistically significant, caught myself. The conclusion, there is no significant difference in the hours per week men study compared to women. So this is a negative study, right? But you should be feeling a little strange about that, right? I mean, the p-value is greater than 0.05, negative study. So we would just say, oh, there's no difference. Everyone studies the same. But you probably feel like I didn't interview enough people, right? I only had 3 in each group. You're not that confident in my results. So did we disprove our hypothesis? So we might have hypothesized that, let's say, women studied more than men. But we examined our data and found that statistically speaking, there's no difference in study time. Studies where the primary outcome has a p-value greater than 0.05 are traditionally referred to as negative. Is the case closed? The answer is no. This study was underpowered, not really negative. What's the difference? An underpowered study is one in which not enough individuals were enrolled or data points obtained to draw a meaningful conclusion. I just didn't get enough people. A negative study is one where enough individuals were enrolled to show that there is no statistical difference between the treatment and control group, or between the sexes, or something like that. So substantial difference here, and this is incredibly important, the distinction. Negative studies are wonderful things. They enhance how science works. They draw us in new directions. They reject our old, worn-out thoughts about how the world works around us. A truly negative study that is compelling and shows no difference, that shows this drug really doesn't work, takes science in a new direction. Super valuable. An underpowered study does none of that. It doesn't tell us this drug doesn't work. It doesn't tell us the drug works. It tells us absolutely nothing. In fact, you can make an argument that if you were to enroll a patient in a study that was underpowered, that didn't have any chance of coming to a meaningful conclusion, you were doing that patient a significant disservice because you're exposing them to a risk of an investigational drug or something like that, and there wasn't going to be even any societal benefit to their participation in the study because the study wasn't going to be able to conclude anything one way or another. So underpowered studies are hugely, hugely problematic. So now we need to give you some skills to figure out whether the study is negative or underpowered. So let's look at a real study. So this was a study close to my heart for several reasons. The effects of improvisational music therapy versus enhanced standard care on symptom severity among children with autism spectrum disorder. So this was a randomized trial. They took kids with autism spectrum disorder, and half of them got standard care, and half of them did this improvisational music therapy, and they were doing drums and like flute and stuff, and kind of cool. And what they looked at is the social affect score, basically where lower is better. And you can see the results here. You can see that both trend lines kind of go in a downward direction, but they don't look like they were that different. And in fact, the mean difference was just 0.06 with a p-value of 0.88. So that 0.88, clearly much higher than 0.05. Is this study negative or is this study underpowered? Let's figure it out. Well, what do we know so far? We know one thing, they got a lot of kids in this study, okay? There were 400 people randomized. That's pretty big. That's a heck of a lot better than my women versus men in studying study, okay? So that feels good. The p-value equals 0.88. That's on the high side. Does that tell you anything? Well, no. Neither the sample size of the study or the magnitude of the p-value tell you anything about whether the study is underpowered or truly negative. I'm sorry, you're going to need something else. And that something else you need to know is what is the minimum clinically relevant difference between the groups? What is the minimum number of hours per week that you think is relevant to how much time a given gender studies? Okay, so I'm giving you an example here from prior. We need to decide, as we're looking at the study time, what's the minimum time that I would care about, right? If I showed you that men studied for 1 minute per week longer and that was statistically significant, would you care? Does that matter? Probably not, right? What's the minimum effect on reducing blood pressure that would make you decide to give or take a new drug? All right, so if I have a new drug for blood pressure and I want to take someone whose systolic blood pressure is 140, what's the minimum amount that that drug should reduce blood pressure for me to say, yeah, I'm going to give it to you? Is it 10 points, get you from 140 to 130? Is it 5 points? Is it 1 point? Okay. In the case of the autism study, what is the minimum benefit on the social affect score that would make you want to treat a patient with autism with improvisational music therapy? Okay. We need to define that minimum. I'll show you one in a sec. But you may be thinking right now, like, wait, isn't it anything? Doesn't anything matter? And the answer is no, because every treatment has a cost. Some of those costs are monetary, some of those costs are in the form of side effects, some of those costs are just costs to society. But if I had a pill that would reduce your blood pressure from 150/80 to 149/80, okay? A true effect, statistically significant. I'm proving this pill drops your blood pressure by 1 point. I'm not going to give you that pill, right? I'm not going to ask you to spend money on a pill to go from 150 to 149. That is not clinically significant. That is not the minimum clinically significant difference that I'm looking for. There may be better alternatives for one, right? There are other pills that are going to do better. Why wouldn't I just give you one of those other pills? And so some minimally important difference needs to be specified. And a good medical paper will actually tell you what the authors feel is the minimum clinically important difference. They'll actually write that down. Worse papers won't tell you that information. You'll have to kind of think about it for yourself. So how do we use the minimum clinically important difference? Okay, I want you to focus down here on this measurement of effect size. And we're gonna take a minute with this. So we have a spectrum here going back and forth. In the middle, we have no effect. The drug doesn't work. Now, in every study is going to report an effect size, and it's going to give a range. Remember when we talked about margin of error? When we say we have a measurement, but we're not sure, it could be somewhere between these two numbers. Okay, that in medical studies is often referred to as a confidence interval. I'm pretty sure that the true value is somewhere between these two numbers. In fact, I'm 95% sure that the true value is somewhere between these two numbers. So a study is always going to report the absolute difference between the groups, okay, the number of points of blood pressure difference between the groups, and then a range where they think the true difference could lie, just like when we're doing that polling for presidential campaigns. All right, so that range is here. Now, in a negative study, that range will cross no effect, okay? Because in a negative study, the authors are saying, we can't really rule out that nothing is happening here. In other words, the effect of this drug may well be zero because our margin of error, our confidence interval crosses zero. This is like the statistical tie that they talk about when they're polling candidates and they say, oh, well, you know, he's got 45% and she's got 44%, but they're within the margin of error. It's a statistical tie. They're just saying there's no difference. We can't, it's too fuzzy, okay? So that negative study is going to cross the no effect line. If it didn't cross the no effect line, it wouldn't be a negative study, actually. It would be a positive study. So we know it's going to cross the no effect line. But it will exclude the minimum clinically meaningful difference. Okay? So the minimum clinically meaningful difference is some distance away from no effect. In our blood pressure example, maybe this is 10 points of blood pressure. or 5 points of blood pressure. The negative study is going to say the drug doesn't work and I'm excluding the minimum clinically important difference from possibility. In other words, if this is how well the drug works, I am really sure that there's almost no chance that it does work to the degree that we would want it to work to use the drug. Okay? So we're basically saying for a negative study, I've excluded the minimum clinically meaningful difference. So basically, yes, any given study has some imprecision, but even within the limits of the imprecision of this study, I still am sure that this drug isn't going to give me my 5 points of blood pressure control I want. That is a negative study. This drug is not going to be used. Okay. An underpowered study also is going to cross no effect, because remember, it's a negative study, so it has to cross no effect, but it includes the minimally clinically meaningful effect. Okay? So for that hypothetical blood pressure study, we'd say, well, the possible range of effects for this drug range from no effect whatsoever to including an effect that's important, 5 millimeters of mercury, if that's our minimally clinically meaningful difference. So if the possible range of effects includes nothing, but also includes the effect we would want to prescribe the drug, then that study didn't tell us anything. It didn't tell us anything whatsoever. It is underpowered. So you're going to look at the confidence interval of the effect size. If it includes the minimum clinically important difference, that is an underpowered study. If it excludes that, it's a negative study. Let's use 2 examples. Okay, so in our Yale men versus Yale women study, the mean difference was 4 hours per week. That was just the average difference. Now remember, I told you the p was 0.83. It's a negative study. The range, my margin of error in this study, because I only enrolled 6 people, because it was a pretty bad study, right? The range is from negative 29 to 37 hours. Okay, so there's a difference. Any value between negative 29 and 37 hours is a plausible, true result if I were to measure every single Yaley on campus. Does this range include a minimum clinically important difference? Yeah, absolutely. I think maybe a couple of hours would be relevant to me, and a couple of hours clearly falls between negative 29 and 37. So this study is definitely underpowered. Now in the autism study, the mean difference in the social affect score was 0.06 in favor of the improvisational music therapy, but the range, the margin of error, went from negative 0.7 to positive 0.8. Okay, so it crossed 0. That's why it's a negative study. The p-value is 0.88. What is the minimum clinically important difference? Well, on this particular scale, and there's no reason for you to know this, but it actually wrote it in the paper, the value is 1. So 1 point better would have been meaningful. This range excludes 1 point. It tells us, yes, we measure with some imprecision, but even accounting for our imprecision, we are very confident that the true effect does not include that minimum clinically significant effect, in which case this is a truly negative study. Improvisational music therapy is just very unlikely to get you a significant benefit in terms of the social affect score in kids with autism. Now, this ties into a concept called statistical power, which is basically it's basically the idea just flipped around. So I've shown you how to take an effect size and decide whether the study had enough power, was underpowered or not. But really what scientists want to do is flip this around, do the reverse. In other words, before they do a study, they figure out what the minimum clinically significant difference is, and they back calculate to see how many people do I need to enroll in my study to have enough people to make sure it's not underpowered. So that's called a power calculation, and many papers will report what they did for their power calculation. And they'll say, oh, and we wanted to make sure we had enough power, and we calculated that we needed to enroll 800 people. And they'll say that in the paper. And then they'll show you how many people they did enroll. And sometimes they say, well, we knew we had to enroll 800 people, and we enrolled 810 people because we were afraid some people would drop out. Or sometimes they say, we knew we had to enroll 800 people, and we enrolled 300, and then we ran out of money, so we stopped the study. Okay, so you want to look at that. That's called a power calculation. It all boils down to probability. You'll never be 100% sure of anything in statistics, so most studies are, quote, powered to about 80 or 90%. They say, we are 90% sure if we enroll this many people that we will not have an underpowered study. We'll have an adequately powered study. If it's negative, it is truly negative, and you can take that to the bank. So our take-home points, the key to interpretation of a negative study is the minimum clinically important difference. You've got to figure out what that is. If the confidence interval doesn't exclude that value, the study is underpowered. If the confidence interval does exclude that value, then the study is negative. Underpowered studies are ethically problematic. They are bad. They are not good for science. Negative studies are a cornerstone of good science, and we should publish them and laud them and celebrate them just as much as positive studies. Power calculations can and should be done before the study starts to ensure that underpowered studies don't occur often. That's my hope. I hope it's yours too as well from now on. See you next time.